So let's start. Hi, everyone. I'm Lior Sidi. Woo! I'm leading, in the past 4.5 years, I've been working a lot around customizing machine learning, AI models for Wix needs with many different companies. Lately, we were focusing, as you know, on large language models, customization, understanding very deeply how they work in order to make them even more accurate to Wix. This is possible thanks to amazing data science group. This is specifically part of the group that specialized on LLM customization for knowledge. And what I'm going to present today is how we actually customized an LLM for Wix needs so it will outperform even GPT. And this is possible thanks to the amazing team of AI researchers that read the papers, understand how the models work, the data curation that are responsible. We're going to talk a lot around the data, the benchmarking, the evaluation process, how we do error analysis and learn as we go, that they work closely with the labeling and QA team that allows us to actually scale these models and learn from them. And all of this is also supported by amazing infra and infra platform and machine learning engineers that are part of the group as well. So applause to them, even though you don't know what we've done exactly, but so let's start. Assuming most of you are customizing LLMs using prompts, okay? So we have a prompt that we pass into an LLM, and we hope to get a certain output. Now let's take a Wix use case, right? So a cool example is, for example, you wanna given some user input or any kind of input, you want to understand which Wix feature it's relevant for. So the input can be the editor for agencies and enterprise. So you will hope if you give it to GPT or whatever vendor LLM to get the right results, which might be editor X. You know it's wrong, right? So today we have Wix Studio. It means that the models are not really up to date with recent information we know at Wix. They are not really custom to Wix yet. Another great example is, let's say you wanna understand what is the next best action for a Wix user, for a Wix website. And the input of this for this prompt would be a jewelry store that have a low traffic and the conversion rate is pretty good. So you want a prompt that will recommend the next best Wix feature for this input. And if you use out of the box, vanilla LLM, you will get something like high quality visual. That doesn't really make sense because we said we have very low traffic but good conversion rate. We actually wanna use SEO flows or Facebook ads. So again, the LLMs don't really get Wix what we actually expect the LLMs to behave. And this is where, unlike the alignment process that Maxim just talked about, that we want them to be aligned to have like a chat capabilities and things like that, here we want to control what the LLMs actually answer, okay? So we talked about prompt, how we can customize LLM. We can keep improving the prompt using prompt engineering with different guidelines. We can also use RAG. RAG is Retrieval Augmented Generation, where you actually add more information to the prompt from your documentation, from different internal knowledge you have in your business. Another process is prompt optimization, where you iteratively improve the prompt. These are all like techniques for improving only the prompts. When we're talking about improving directly the LLM, we're talking about fine-tuning. So in order to fine-tune an LLM, you have several ways to do it. The most basic one is doing one task. So it's one task fine-tuning. This kind of capability, you take your prompt, you just specifically have like one task that you want to tune. This is what is accessible today in OpenAI and all the vendors, doing only one task at a time. Then you can do alignment that also have fine-tuning capabilities inside, but it's under changing the LLM to do something. And today we're going to talk about multitask training. We actually want the model to learn several tasks at the same time, and we call it domain adaptation, not only us, the entire research community. And it actually requires us to have a lot of domain data from different sources with different tasks in order to capture this multitask capability, right? So if it's not clear yet, let's just understand how these capabilities are in on two scales. One scale is given the task, like the capability of tuning LLM, how many tasks it's actually able to solve versus the complexity of developing it. So you can see that the prompt engineering is the most simple one, but it captures very narrow element of, it really relies on the guidelines you put. So as you go here right, you can actually see that the domain adaptation is becoming a bit more complex, requires a lot of more data, development, understanding how the models actually works, but we can capture more tasks and more capabilities. So, if I were you, it's not necessarily the first thing that I would do. You need researchers, you need infra, so you need a lot of work. This is why we in the data science put our effort in it. And it requires a lot of data, a lot of efforts, as I said. And by the way, we're going to see later that even the prompt engineering, prompt optimization shows very good results. So it really depends on the use case when you want to do that. But we're going to talk about it later. Cool. So how we actually, customizing an LLM, applying domain adaptation? So first of all, you need to start with a base LLM. It can be like stripped off, empty LLM with not trained at all, or a pre-trained LLM. Some LLM that was already aligned for chat, for example, that already knows about the world, knows it was trained by someone. Then we can take this base LLM and apply a step called domain adaptation training, where if your model knows nothing about your domain, maybe you have like very niche, cheap domain that you want to find the LLMs to know, then the LLM, as they come in a pre-trained, they know nothing. So you want to train it on the domain data. You want it to learn all the basics, all the things. So and this requires billions of tokens, billions of data to train such this process. The next step is that you take the model that you train and you do a supervised fine-tuning, where you take the domain data, extract several tasks that you want the model to know, the multitask that I mentioned, and you do another fine-tuning process. And in the end, you get the domain-adapted model. So this is like a very high-level sketch of how the domain adaptation flow looks like. At Wix, we have a dilemma, we have a challenge. First of all, we don't have billions of tokens that we wanna train the model from scratch. Different reasons for that. Some of it, like it's about the quality of the data, privacy maybe, but different concerns why we don't wanna do that. So we cannot really apply the domain adaptive training. But do we need? Actually, if you look at LLMs, they already know a lot of things about Wix, about website building, about our features, as I showed you before. They know some, so we don't necessarily need to train them from scratch. They already know something. So that's one. The second thing is that we do have at Wix a lot of high-quality data that we can use to train the tasks, the multitask element. So we can actually focus on that. We have a lot of data curated along the years, a data-driven company, so we can use it. And basically, we can directly move from a pre-trained LLM, choose the right pre-trained LLM, and use supervised fine-tuning on our quality data. Okay? So this is how very high-level components that we are actually going to take one after the other and understand how we constructed the final adapted model. So we have different data sources at Wix that actually feed two processes. The first process is the modeling, the training data set that actually allows us to fine-tune the model and train these tasks. So that's the first path. The second one is the evaluation part, where we can curate test set and evaluation benchmark to understand our model performance and then see where we stand. In the data science, and hopefully also in the future in software teams, we all the time starts with evaluation, okay? Evaluation is the first things that we're going to touch because we need to understand where our model stands. Maybe we don't need to do domain adaptation in the first place. We need to understand what is our north, where we want to head. So we start with evaluation. One very cool technique to understand or to quantify the knowledge of a model is to use a technique called knowledge probing. Basically, what you're doing, you're taking a question and answer pair, and you turn it into a quiz, a multi-choice. The reason you want to do that, it's because if you just want to evaluate question and answer, and you want just to evaluate the answer, it's very difficult. It's a full text. It's very noisy to see if really the answer is similar. There are many reasons for that. And by having 3 other alternatives and asking the LLM, given this quiz, please come up with the best option, you actually get 2 capabilities. The first one is the knowledge. You know that if you select the right option, it's correct, so it contains the knowledge. And the second one is the instructive capability. It's able to follow instructions, so you actually can evaluate both. And it's very important when you structure this quiz, you need to make sure that you have a very easy option and very hard option, and the structure of how they first need to look the same, okay, to the correct one. Okay, so it really be challenging. Cool. So because we have the evaluation process, we can see what's the performance of the current models that we had. So back then, in March 24, there was only GPT-4, not 4.0, which really changed everything, and we might talk about it in the end. Not might, we will. But if you look at these models, so GPT-4 had very high cost and high latency. The open source Llama was very low cost, like very cheap, and if you did it on your machines, it was even fast. And the common model that was the go-to model was GPT 3.5. It was used in most production prompts that we have, and this was our go-to, but also in respect to cost and latency, it was something in the middle. So we have this performance, and we have the different evaluation processes that we have for question answering, for intent classification, which is a data set that we have for a chatbot that, given a user input, we understand what is the intent, the Wix intent behind that, and the quiz that I just explained. So we have these three benchmarks, and we estimate the performance of the models, and we really see that GPT-4 outperforms all of them. The Llama 2 13 billion chat is actually really underperforming compared to the rest. And the question that we want to ask ourselves is, can we actually take this Llama model that is possible to do domain adaptation? Okay, this open source model allows us to really play into the weights and really come up with advanced domain adaptation techniques, unlike OpenAI and other vendors that are much more close. Can we make it much better and even outperform GPT? Cool. So starting with data, the data sources we had that we are aware at Wix, it was a very cool process that we've done with the curation where we mapped different data sources that we have. We have like article types of data source like KB posts. We have conversational data from live chat and Wix forms and name it, and tabular data, which is the different systems and tables that we collect at Wix. All of them are, might be very high quality, very beneficial data sets for training such model. And we prioritize these data sources based on their quality, how their size, their freshness, their value, how much they clean, and what is the effort that we need to do in order to enhance them and transform them into a task that it's easy to train and evaluate. So we have this heat map that by the way, there are many more data sources that are not shown here. That actually allowed us to prioritize which data source we are starting with. Keeping in mind, we want to use these data sources also for evaluation and also for training to create these benchmarks. So how we actually take these data sets and turn them into data that we can train an LLM. So we have the data source, and we have something called Task Augmenter, which is a process that can take the raw data and turn it into an annotated task that an LLM can train on. For example, in articles, we can apply reading comprehension tasks. We can also take the conversation and apply LLM to extract the task. And for the tabular data, we have like heuristics and rules that allowed us to create this annotated data. For example, the reading comprehension, you can see here, this is how it looks like. We have an article, and we can ask the LLM, please, given the content of the article, please write a title. So we know this, it's very easy to extract it, and we ask the LLM to generate titles. Another thing, a very cool techniques of reading comprehension is detecting paragraphs that contains a lot of domain-specific phrases and keywords, and ask the LLM, given these keywords, please write informative paragraph about Wix that contains these. And actually, this process allows the LLM to understand the relation between Wix features, Wix information, and learn something and learn more knowledge. Another very cool process of the internal system that we have the issue system that maps between an issue concern and the product features and many other different elements that we have. So we can also extract a business task given the user inquiry X, which product it's related to, and we have the answer itself. Also to understand the relationship between issues and the product. Another very cool system that we have is the success system that recommend features for Wix. So given a Wix user that have a certain industry, certain site, given the list of features, which one is the best, we already have this labeled because it was recommended and we saw what the user chose and was it successful for them. And we can also have the model train on this. So after we have a lot of different task augmentation processes that allowed us to create huge label data for LLMs, we need to sample them, balance between them, and create a training data. This process of balancing is very, very important and delicate. We actually still want to have general data in the data set, so we don't have catastrophic forgetfulness of general information. So we balance between Wix data and general data. And now the last part is the modeling. So we have balanced the data, we created a training data set, and we want to train our model. Training model process goes like this. We start with choosing the base LLM, as I mentioned. In our case, it was Llama 13 billion chat. It was a very common model that was used by a lot of research groups and also holds chat capabilities that we wanted. Second, we are training this LLM. We tried different techniques. One of them was full-weight fine-tuning, which we trained the entire network. Another one, efficient parameterized fine-tuning that we actually chose, which is LoRa, that just train partial of the weights in a certain manner. It requires much less data, and it's much faster to train, and even can be faster using QLoRa. I don't have time to go into the details here, but that's the idea around training. And as we train and as we progress, we actually evaluated using our benchmark and other testing data set. We monitor the network, the LLM loss, and so what works and concluded. So after we evaluated, we have this amazing table, which now it's a bit, I think you can read it better than before, but what I want you to focus is this second line, the Llama 2 fine-tuned model. This is our, what we call it Wix LLM, but this is our fine-tuned model. You can see that it's still, it's the second best. It's not as good as GPT-4, but it's slightly better than GPT 3.5, as I promised in the beginning. And the very interesting thing that you can see is how we actually increase the performance of the base Llama to be even better than GPT-3. We also tested the task-based fine-tuning of OpenAI. This is the last line. We actually took GPT 3.5, we fine-tuned on the dataset, and we actually hurt the result of GPT 3.5. The reason for that is because the fine-tuning of OpenAI, as I mentioned, I think it's the fourth time that I'm mentioning it, it's optimizing only for one task at a time. And our training dataset contains a lot of tasks, and it actually confuses the model and create much worse results. Cool. So summing it up, we have these components. We started with the sources, we mapped them, we prioritized them. Then we used the data set from the data sources to train the model. We evaluate it iteratively and come with a good performing model that we can know that is good and customized for Wix. I can tell you that what we actually learned from this process is how to work with local models and deploying them. It really helped the code generation and Astronova research team from the data science and other different models. Now we have a lot of high quality benchmarks that we actually use to evaluate LLMs vendors with data that they didn't know before, so we can really get the performance on Wix. So also if you are using you are using LLMs and some of these data sets interests you, can actually use them as benchmark and see which model is more suitable for you. Is it intent classification, question answering, whatever you want. And actually, as I mentioned, GPT 4.0, it's really changed everything. So GPT 4.0 is still, improvement, a lot of improvement in performance, in cost, and still maintaining a very good performance. So we decided, in respect to Wix LLM, to put it down a bit and focus more about knowledge representation, how to read better, how to reconstruct the KB of Wix in order to improve RAG capabilities and understand Wix better from a different perspective, not necessarily fine-tuning. So this is what we've decided, and this is what the team actually focused today. The next gen RAG that's going to be used across all the platform, the agent platform and the AI assistant and customer care. So thank you very much.